Okay, we are back with some quick math. Like the video, subscribe to the channel, and share it with anyone doing pure math, technical math. I'm sure they'll benefit from it and help the channel grow. Okay, let's deal with this question. So this is Euclidean Geometry. This is grade 12 content. Let's first read the information that's given to us. So it tells us PQT is a triangle. The triangle is inscribed inside a circle. It's inside the circle. The vertices are all on the corners, as we can see, right? So it touches there, touches there, touches there. Okay. They tell us that OA is parallel to QR. Okay, so where's OA? That's this one. And QR, that's this one. Okay, so they tell us that it's parallel. The majority of the time, the information that is given in the description is on the picture. So the fact that it's not given here, well, sometimes you will see it like that, but the majority of the time it is on the picture. Okay, anyway, so we know they are parallel. Let's see what else they tell us. They tell us that PA is over here, is equal to QA. So that's over there. Okay, so they tell us those are equal. So before we even read any further, we already see some things, right? So if I look in this triangle over here, I have the fact that these are equal. I have the fact that these are parallel. So I already have two of the four things we know for our midpoint theorem, right? So we know that once you have the midpoint theorem, that there are four things. Let's look at it quickly. Okay, so the midpoint theorem tells us this: if these are equal and these are equal, right? So if these are equal to each other and these are equal to each other, so if those two are true, the other two things are true. So what other two things? I'm saying that this one and this one will be parallel, and this one is half of this one. Okay, so there are four pieces of information. If two are true, the other two are also true. Okay, so let's I'm going to say the exact same thing again. Now I'm just going to put it in a different order. So if this one and this one are equal, and this one and this one are parallel, so those two are true, then the other two are true. What's the other two? This one and this one will be equal, and this one is half of this one. Okay, I can say it in as many different orders as you would like, right? But provided two are true, the other two are also true. Okay, so if this is half of this one and this is equal, then the other two is true. So this one and this one is equal, and this one and this one is parallel. So all of those things as many times as you want to hear it. There's four pieces of information. If two are true, the other two are true. So as we've seen so far, just by the information that we've already read, you have two things that are true, so the other two will also be true. We'll probably need that as we get into the question, but for now, let's continue reading. Next, they tell us that PB, that's over here, PB is equal to BT, that's over there. Okay, so that's all the given information. And now let's look at the question. So the first part, they're asking us to prove that AB is this line, is equal to, well, not equal to, rather parallel to QT, that's this one. So we want to prove that those are parallel. Okay, so let's look inside another triangle of ours. If we look at this triangle, right, so that is triangle PQT. If you look inside PQT, okay, what did I do there? If you look inside PQT, you can see that this one and this one are equal. This one and this one are equal. So there we already have two of our pieces of information. So the other two are going to be through this line and this line are going to be parallel to each other, as well as the fact that that line AB is going to be half of QT. Okay, so we haven't written down anything yet, but we can already see that. Let's get into writing down how this is going to look, right? So we will, right, let's get into writing this out. So we will say that PA is equal to AQ. This is given. We'll also say that PB is equal to BT. That's also given. Right, that's given. Now we are going to say that AB, so right, because of those two statements, so we'll say therefore, so because of the above, we now know that AB is parallel to QT, Our reason for that is going to be midpoint theorem. Midpoint theorem. Right, that is the word theorem, midpoint theorem. Okay, great. So we have done the first part of the question. We have proven our parallel lines. Next, they want us to prove that O is the center of the circle. Okay, so let's not make the assumption that O is the center. They don't give us that information anywhere, so we can't just assume that O is the center. We need to prove that O is the center. So how would you prove that O is the center? You would need to prove this line over here, which is PR. You would need to prove that PO and OR are equal to each other. If PO and OR are equal, then O would be the center. Right? They do tell us that PR is a diameter. Okay, so they need to give us that information. So let's see, how would we prove that? Let's see, what triangle would we look at? So okay, it was the green one, the one that we've already drawn there, right? So we know in our green triangle, well, let's color it in so it's nice to see. We know in triangle PQR. So PQR that I am coloring in here for us. Okay, there we know that PA is equal to AQ, that was given to us. We know that OA is parallel to QR, that was also given. Therefore, PO is going to be equal and OR is going to be equal. Okay, let's write that down. So we are going to say PA equals AQ. That's also given. This is the second part. This is B. Let's just number these fast. That's B. This is A. That is given. We are going to say AO is parallel to QR. Also given. Okay, so based on those two things, that is given. Based on those two things, again, we now know this one is equal to that one, midpoint theorem. So we'll say PO is equal to OR, reason, midpoint theorem. Okay, midpoint theorem, that's theorem. And therefore, O is the center. Okay, that was easy enough. And then the last part of the question over there, they want to know that BORT is a trapezium. So the only piece of information that we know or that we need to be able to prove a trapezium is one pair of opposite sides are parallel. Okay, so let's look where is BQR2. Let's put this in some other random color. BORT. Okay, so let's color that in. So this shape over here, we need to prove that it's a trapezium. So that means we just need one pair of sides to be parallel. Okay, so clearly we are going to need to prove that BO and RT are parallel. We've just proved that PO and OR are parallel. We were given that PB and BT are parallel. So therefore, with midpoint theorem, we would know that BO, RT are parallel, and that's going to be our trapezium. Let's write all of that down. So we'll say PO, OR. So this is C. PO equals OR. Right, we've proven that, so that's go proven. That word is proven. And we know PB equals BT. PB equals BT. That was given information. So because of those two things, we now know BO is parallel to RT. RT, that is midpoint theorem. And therefore, BORT is a trapezium and let's say they're one pair of sides parallel. Right, so that was that question. Good luck.